In the vast cosmos, the number of stars and planets is unimaginably large. In our galaxy alone, the Milky Way, there are at least 100 billion stars, and in the observable universe, there are around 2 trillion galaxies. This enormity raises a crucial question. Are we alone in the universe? Science doesn't yet have a definitive answer, but many believe it is unlikely that we are. This video explores the reasons why finding advanced extraterrestrial life could be bad news for humanity. The Fermi Paradox. It all started with a famous discussion during a dinner in 1950. Here, physicist Enrico Fermi posed a troubling question. Where is everybody? Despite our efforts to search for extraterrestrial signals, the universe has remained in a great silence. Fermi suggested several possible explanations. Interstellar travel could be impossible, not worthwhile, or advanced civilizations might not live long enough to contact us. However, the development of technologies like wormholes could change this perspective. Enrico Fermi, an Italian physicist, raised his famous paradox due to the contradiction between the high probability of extraterrestrial civilizations existing and the lack of evidence for them. Fermi argued that if there are so many stars similar to the Sun that could host Earth-like planets, and if many of these stars and their planets are much older than our solar system, then there should be advanced civilizations that have already developed interstellar travel. These civilizations should have colonized the galaxy, or at least communicated with us. The absence of any tangible evidence of these civilizations constitutes the Fermi Paradox. The Drake equation. 10 years later, Dr. Frank Drake formulated his famous equation to estimate the number of extraterrestrial civilizations we might contact. Despite not knowing most of the parameters needed to solve it, this equation kept the debate about the existence of extraterrestrial life alive. The Drake equation is a mathematical formula to estimate the number of detectable extraterrestrial civilizations in our galaxy. The factors it considers include the rate of star formation, the fraction of those stars with planetary systems, the number of planets per star system with conditions suitable for life, the fraction of those planets where life actually arises, the fraction of life that develops into intelligent civilizations, the number of these civilizations that develop detectable technology, and the length of time these civilizations are detectable. The Great Filter. One of the most discussed theories is the Great Filter, proposed by Robin Hanson. This theory suggests that there is a barrier in the evolutionary process that prevents civilizations from reaching an advanced technological level. If the Great Filter is in our past, we may have already overcome it. If it is in our future, our civilization might be destined for extinction. The concept of the Great Filter addresses the enigma of the Fermi Paradox by suggesting that at some point between the formation of a planet suitable for life and the development of a technologically advanced civilization, there is one or several extremely difficult barriers to overcome. These barriers could be cataclysmic events, biological or technological limitations, or even the tendency of advanced civilizations to self-destruct before reaching a point of interstellar communication. The location of this filter is crucial for our future. If it is in the past, our existence indicates that we have already overcome the hardest obstacles. If it is in the future, it could imply a grim destiny for our species. The Dark Forest Hypothesis. Science fiction writer Liu Cixin proposed that advanced civilizations hide their existence to avoid being attacked by competitors. This theory suggests that any civilization that reveals its presence would be quickly eliminated, which could explain the Great Silence. In his novel, The Three-Body Problem, Liu Cixin introduces the idea that the universe is a dark forest, where all advanced civilizations hide to avoid being detected and destroyed by other civilizations. According to this hypothesis, intelligent life acts with extreme caution, hiding and avoiding transmitting detectable signals. The logic behind this behavior is the assumption that any other advanced civilization could be a potentially lethal threat. This strategy of silence and concealment could be the reason why we have not detected signals from other civilizations. The Serengeti Hypothesis. Another intriguing hypothesis is that our universe could be a kind of natural reserve, monitored by a superior civilization that avoids interfering with us. Like animals in the Serengeti, we might be unaware of the existence of our keepers. The Serengeti hypothesis suggests that advanced extraterrestrial civilizations could be observing us without interfering, just as humans protect and observe wildlife in natural reserves. This theory postulates that these civilizations may have a non-interference policy, similar to the Prime Directive in the TV series Star Trek. The purpose of this policy could be to allow us to develop naturally without the influence of advanced technologies or knowledge. This hypothesis could also explain the lack of evidence of advanced extraterrestrial life, as any detectable interference would be strictly prohibited. The simulation hypothesis. Nick Bostrom suggested that we might be living in a simulation created by an advanced civilization. If this is true, the Great Silence could simply be part of the rules of the game, designed by the creators of the simulation. The simulation hypothesis posits that our entire reality could be a simulation generated by an advanced civilization with immensely superior computing technology. According to Bostrom, it is possible that an advanced civilization has developed the ability to create simulations of entire universes, and we could be conscious within one of these simulations. In this context, the Great Silence could be an intentionally programmed feature within the simulation, limiting our access to information about other civilizations to fulfill certain objectives or experiments of the simulators. The rare Earth hypothesis. Finally, the rare Earth hypothesis suggests that complex life is extremely rare in the universe. Peter Ward and Donald Brownlee argue that the emergence of complex life requires a series of exceptional coincidences that might be unique to our planet. The rare Earth hypothesis argues that while microbial life might be common in the universe, complex and multicellular life is much rarer. This theory is based on the idea that a series of very specific conditions and improbable events were necessary for complex life to arise on Earth. These factors include the presence of a planet with a stable orbit in the habitable zone of its star, the existence of a large moon that stabilizes the planet's axis, a suitable atmosphere, and events like asteroid impacts that may have accelerated evolution. The combination of all these factors could be so rare that Earth might be one of the few, or perhaps the only, planets to host complex life. The search for extraterrestrial life is a journey full of wonder, fears, and deep philosophical implications. We are at a crucial point in our history, where questions about our solitude in the cosmos take on increasing urgency. Each of these theories offers a different perspective on our position in the universe and the possible threats and opportunities we might face upon discovering advanced extraterrestrial life. As we advance in our search, we must confront the possibility that finding advanced extraterrestrial life might not be the blessing we imagine, but a test of our ability to handle the unknown and potentially dangerous. This perspective forces us to balance our enthusiasm for discovery with prudent caution. Finally, considering all these theories and their implications, we must face the deepest question of all. What does it mean to be human in a universe potentially full of life but so far silent? The answer to this question will not only define our search for extraterrestrials, but also our own identity and destiny as a species. Are we prepared for the consequences of discovering that we are not alone, or would we prefer to remain in the relative safety of our cosmic solitude? These questions and many more will stay with us as we look to the stars, with a mix of hope and fear, hoping that someday we will get answers, but aware that those answers could change everything we know about ourselves and our place in the universe.